An organization is a collection of people working together under a defined structure for the purpose of achieving predetermined outcomes through the use of financial, human, and material resources. Success of any organization is a function of the capabilities of the individuals rather than the way in which they are organized. This lecture provides information about the background of organizational structures. It describes a broader concept of the organization as a complex system in its design as an architecture that includes work and social components, in addition to formal structure. It examines organizations through several different lenses: historical, system models, and design or structure. The clinical laboratory is typically an organization within an organization. It functions as part of the larger health system and provides specific services that are vital to the overall mission of providing patient care. Fundamentally, a look at organization should help answer the question, how do we divide up the work? Max Weber's rational legal system required a strong hierarchy of authority, extensive division of labor for optimum functional performance, impersonal rules and rigid procedures that account for nearly every contingency and decision making based on rules and tactics developed to guarantee consistent and effective pursuit of organizational goals. In the Principles of Scientific Management, Frederick Taylor dealt with the problem of how to get more productivity out of workers and used time and motion studies to break jobs into similar repetitive tasks in order to find the best way to do a job. In the introduction to his book, The Principles of Scientific Management, Taylor states, "In the past, the man has been first. In the future, the system must be first." Taylor advocated a strong division of labor between management and worker. It was the manager's job to understand the task and plan a method of executing it, and then coerce the worker to do it by motivating the worker with pay. In short, these studies, which influenced the organization of the workforce through the 1960s, suggested that informal social structures had much to do with the way an organization runs. Just doing their job left workers feeling alienated and dispirited. Formal organization provides the direction and the stability of the infrastructure. The informal organization has well developed social structures, histories, and culture. Informal groups have a powerful influence on productivity, sometimes more so than economic incentives. The social and technical parts are jointly optimized in contrast with traditional methods that first design the technical component, then fit the people to it. Implementation of socio-technical systems is highly participative, involving all relevant stakeholders and promoting employee involvement at all levels in the work design. Sharing of information, knowledge, and learning is characteristic of this approach. In the context of clinical laboratory, this means organizing a department by considering the instrumentation and technology and by focusing on people issues, communication, and social interactions. In 1961, after observing trends in many organizations, Burns and Stoker described a range of organization management structures that they referred to as mechanistic and organic structures. A mechanistic structure may be appropriate in an environment of slow change and relative stability. The organization is highly structured with direction and communication from the top down and relies on authority obedience relationships. In the extreme, there is centralized decision making, strict division of labor, and insistence on loyalty and conformity to policy and procedures. At the opposite end of the mechanistic structure is the organic structure, which is preferred in an environment of high change. This system features decentralized decision making and a fluid design which facilitates flexibility and adaptation and encourages a wide sharing of responsibility. In the 1980s and 1990s, different types of process improvements influenced organizational structures in business and healthcare. French and Bell summarized the variety of interventions that have affected structural changes in organizations over the past several decades in this slide. Systems contained within larger structures help to categorize the large amount of information managed by the organization. In contrast to the mechanistic and organic systems presented earlier, this section will provide comparisons of the closed, open, and congruent systems. Using a simple abstract model, such as a biological organism, organizational systems can be thought of as interdependent, interconnected elements that constitute an identifiable whole. As shown in Figure 2-1, systems exhibit activities that take input from the environment, do something to the input through transformation or conversion, and export a changed product back into the environment. If we look at our organizations as open systems, we can start to see the interactions and influences of one part of the system with others and evaluate the needs of the organization. Open systems share the characteristics presented on this slide. In a relatively stable, slow-changing environment, the closed mechanistic approach may be appropriate. It is a challenge for the laboratory manager to recognize inconsistencies and be able to implement changes that improve the organization. The closed system, being less considerate of external forces, is internally focused. One way of approaching the changes is to look more closely at what must happen within an open system to support a state of equilibrium. The congruence model described by David Nadler shows a little more detail of the elements of an organization as an open system and some of the dynamics involved. In this model, the elements of the transformation process, or more appropriately, the operating organization, are the major components that transform the inputs to the outputs through the implementation of a strategy. In this figure, a congruence model shows the organization as an open system. The following components are represented and their interrelationships are known as arrows. Work, it's the tasks performed to provide the products or services. People, they include skills, knowledge, and workforce expectations. Formal organization is the formal structures, policies, and procedures for performing the work. Informal organization pertains to culture and informal rules and understanding about how the system works. The differences between the open and closed systems are compared in this slide when considering certain organizational elements and behaviors. System models help categorize the many aspects of the system. Structural models show function and linkage of how groups in the organization relate to each other. 5 factors which influence the design and structure of the organization are listed on this slide. 5 structural models illustrate the range from mechanistic to organic networks. These models include functional structure, self-contained units, matrix, process-based, and network structures. Although these models are not exclusive, they illustrate some basic advantages and disadvantages of recognizable approaches. As with the closed system model, functional structure organizations can function best in a stable, controlled environment where the organization is small to medium in size. The disadvantages of the functional structure are that communication among groups can be compromised, with departments acting as silos and focused on only their areas of responsibility. There is a possibility that coordination between departments may become competitive and unresponsive. This slide shows the functional laboratory organizational chart as a traditional multi-layer design. Specialized units such as chemistry, hematology, microbiology, and others may be represented as sections or departments with a hierarchy of supervision and management. This slide shows the functional laboratory organizational chart as a flattened design. In the restructuring of clinical laboratories, efforts at consolidation and creating more cost-effective structures have resulted in a flattening of the hierarchical structure and elimination of some supervisory and management layers. Although there may be fewer steps in the decision-making process, the top-down control remains. Each unit contains all relevant skills and processes to successfully operate. The grouping of disciplines in the laboratory, such as chemistry, hematology, microbiology, in large health system environments with their own functional expertise and supervisory structure are examples of self-contained units. A disadvantage to this structure is duplication of resources and expertise, requiring a larger facility and more employees, a possible lack of work for specialty areas, and feelings of isolation from other specialty areas of the laboratory. Advantages are the ability for each unit to function efficiently, as all resources are included in each unit, and the ability to meet changing conditions quickly. Figure 2-4 represents a self-contained unit or team approach where members of each unit are grouped by function around centralized support and management services. The circles represent overlapping teams, each with specialized functions and tasks. A matrix design works best when the demands of the environment are changing and uncertain, and where there is a high interdependency on technical expertise and specialization. This type of structure promotes skill diversification and efficiency in sharing human resources. The disadvantage of matrix structures is that roles and reporting structures can be confusing and ambiguous. An individual may report to more than one boss and may be asked to assume different roles depending on the team they are on. In the clinical laboratory, restructuring from a functional system with specialty disciplines such as chemistry, hematology, or microbiology toward a production focus as a core or rapid response laboratory may result in the matrixing of technical and production operations responsibilities. The solid lines indicate formal direct reporting, dashed lines indicate informal reporting, circles represent functional departments or teams. The teams are the functional unit of this structure and are self-managed and responsible for all outcomes of the assigned process. Transitioning to this structure can be difficult from traditional hierarchical structures as the approach flattens the structure and can change the focus of the leadership to processes rather than departments. Additional obstacles to manage are drastic changes in mindset and duplication of resources that may be scarce. Figure 2-6, example of a process-based structure. Process-based structures emphasize the lateral relationships in an organization and allow the organization to use resources for customer satisfaction. Network structures are evolving as information technology allows instantaneous access and distribution of data and information. They combine innovation and responsiveness of small entrepreneurial structures with the economies of scale of large organizations. One concept is the human network organization patterned after a browser-server model as portrayed by Harry Dent in Figure 2-7. For a detailed description of a browser-server model, refer to pages 52 and 53 of the Laboratory Management textbook. Network structures have emerged to respond to the dynamically changing environment that is growing more and more complex, interdependent, and client-driven. Figure 2-8 shows a model of three levels of service from point of care to core laboratory in a large geographic region. This networked system depends on strong collaborative leadership, an efficient information system, appropriate clinical instrumentation, and flexible staffing. In general, some trends in organizations will be prompted by the requirements for efficiency, speed, cost effectiveness, and customer or patient focus. Future systems and organizational structures will be driven by trends in technology, diversity of the populations, and flexibility of the organization to meet needs internally and externally, flattening of the structure to provide quicker and more accurate communication, and networks, strategic alliances, and partnerships in the field. Technology advancements continue to evolve, providing faster, more comprehensive platforms that will become more and more accessible. The balance of economies of scale through consolidated platforms, along with the demand for patient-focused testing, will create a healthy tension that will challenge the traditional clinical laboratory system and will necessitate new models for service delivery. Diversity in both the workforce and the consumer population emerges as a key issue to organizational structure, culture, and management. How an organization copes with the different styles of interaction, communication, and appearance will challenge its structure. Flexibility and organizational agility are necessary to respond to demands of patients and healthcare providers. Rigid structures that are bound by rules and regulations will give way to those that can quickly respond with innovative solutions. Structures that are flexible allow greater autonomy and encourage decision making at the point of care. The access to information through more robust technology means less need for the communication and control function managers have traditionally held. In some ways, the role of management is challenged with the automation of management by accessibility of information systems capable of storing and sharing organizational goals, plans, policies, and procedures. Internal signs that organizations are trending toward networks include an increase in direct communications across unit and department boundaries, formation of cross functional teams, and decentralization of services to meet customer or patient demands. Patients will take on the perspective of consumers of the laboratory and other medical information and will expect faster, more efficient delivery of services. This lecture has covered many organizational structures. Laboratory professionals should be challenged to look for new and creative designs to meet the demands of the environment, particularly customers and patients. There is no single structure and no right way to divide up the work. Each organization must evaluate their unique situation and anticipate the future trends. The leadership of the system must find and recognize the future and not be blinded by the day to day business at hand or paralyzed by past practices. We must look at the forces in our environment that will drive change and create new opportunities. Managers must look to align processes and the people in our organizations to carry out strategic plans that will guide us to the organization's goals and vision.